Hi, my name is Kim Trott. I'm the Director of UI Platform Engineering at Netflix. My team works on the Node platform at Netflix, as well as a lot of common libraries and modules that are shared across all of our client applications. So just to talk a little bit about the scale that we're operating at Netflix, we have 69 million members in over 60 countries, streaming 100 million plus hours per day, and that's constantly growing, so not small scale. And today I'm going to talk to you a little bit about how we're using Node, sort of how we got to using Node, some of the learnings that we had, and where we're taking it in the future. So this is the Netflix.com website back in 2013. As you can see, we're still actually using our old style of vertical box art, and also we were not using Node in production. We were running, a lot of people have probably heard people talking about their monolith applications over the conference, and we were right in that same situation, running a large legacy application, extremely long startup times, really slow builds. We had to run on really huge developer machines. So it's really affecting our ability to be productive and move quickly and be able to rapidly innovate and build out all the A/B testing that we do. We're constantly doing hundreds and hundreds of A/B tests to continuously improve our product experience. And it's really hard to do if every time you're making any kind of change for a developer to be able to test it, it takes 40 minutes to start up the server. That really can grind you to a halt. Also, we were running Java on the server and JavaScript on the client. So the developers working on the website had to be really great at a lot of different aspects, really great at building an amazing product experience, as well as dealing with, a lot of back-end, middle-tier aspects. So we were doing a lot of things twice. Pretty much had to write everything twice, once for the server and once for the client. And then there was two ways of doing everything: debugging, data access, rendering. So it's just really difficult to work in that environment. And we had to hire and train people to be really good at all of that, which kind of made you good at nothing. So we'd hit a ceiling. We didn't have the developer productivity that we wanted, and we weren't moving at the pace of innovation that we needed to keep up with the business. So we really want to simplify our stack. Our web application layer was doing way too much. It was really complex. It had a lot of business logic. It was doing a lot of data access. It was directly talking to the hundreds of middle-tier services that we have at Netflix. So we really wanted to simplify that stack down and really turn it into a dumb rendering layer. We was just really worried about routing and view templates and pumping data into those view templates. We also wanted to move the website to more of a single-page application, and instead of rendering each page fully like we were doing with the old site, move towards more of a single-page app. So to really do that, we Node to the rescue. We chose Node for a number of reasons, but the number one was really around the common language. It's really important to us to be able to write the same code and run it, write it once, run it everywhere, have developers who didn't have to do all that constant context shifting between Java and JavaScript and between working on the server side and the client. We were really attracted for the universal or isomorphic aspects that we could get out of running the same language on the server, because we wanted to build that single page application, so be able to leverage and take advantage of all of that code. And then we didn't have to hire people that had to be really great at Java. We could focus on people who are really great at building an amazing product experience, which is what we care about. And that's some of the reasons that we wanted to go with Node. Also really easy to get stood up quickly. With a lot of people know JavaScript, but you can go from 0 to 60 on Node really fast, so you can get something going really quickly. Another angle was performance. Non-blocking async was an attractive aspect to us. We went from 40-minute startup times to sub-minute, so that was a huge improvement. Everyone could move a lot faster. And then, there's a really rich module ecosystem that's all open. A lot of it's open source, available on NPM, and it's focused on the UI needs and UI frameworks and libraries, which is a little bit different than the Java ecosystem. So that's how we decided to start using Node. But let's talk a little bit about what we learned while we were building it out and using it in production. So this is what Netflix.com looks like today. It's running more as a single-page application and a much richer user experience. And just to talk a little bit about the technologies that we're using, this is not comprehensive, but obviously we're using Node. We use Restify as our REST framework. We're using React and actually using it to do server-side rendering, as well as using it on the client. And then we use our own internal but open source data access framework called Falcor to coordinate all the data access between the Node servers and our edge tier, which I'll talk about a little bit more later. A little bit of a trick with React is it's kind of a hack to use React on the server. It's not perfect. It's not something that the Facebook team is using there, so they haven't done a lot of work to make it really easy. So there's some tricks that you have to be careful about. The server-side module lifecycle doesn't necessarily unmount modules, so that can result in memory leaks if you're not careful. So there's some tricks around using React. We'd love to see that get a little bit easier to be able to run it on the server and client more easily. So one of the things we learned is we really had to unlearn our Java instincts and really understand and learn about the characteristics of Node and how it's different. So instead of worrying about tuning the VM, you really, I think, focus more on tuning the application and looking for where you're spending too much time on CPU or you have CPU bottlenecks. Definitely one of the challenges that we faced is memory leaks in production and just learning how to root cause and find where those leaks are coming from. Often we're finding a common source of leaks is from shared global state, and that's just a trick when you're running the same code on the client and server, that if you're not careful about how you're writing that code, that's an easy thing that can happen on the server. So, the promise for us was universal, but it's not for free. You can't just assume that the way that you write code for the client is the same way that you're going to write code on the server. So I think, even though we can write the same code, you have to be really diligent and careful about how you do that. You have to be thoughtful about how you're architecting your code. You can't assume the environment that you're running on. There's a lot of modules that we aren't able to use because they're not written in a way where they can be easily run on both. So you just have to be really thoughtful about what you're doing and make sure that it scales well. 100 milliseconds on the client is just starting to reach user-perceived performance impact. But on the server, that can really affect the performance of the server if you're spending too much time on CPU because of the multi-tenant nature. One bad actor can affect the entire system. So there's a lot of differences there. So I'm not trying to say that we haven't gotten a huge amount of benefit from the common language and the fact that we are able to do this. It's just, we may have been a little naive going into it, thinking it was going to be so simple and so easy and free, and it's really not. You have to think about those things in a different way on the server than you do on the client. We also, realize the importance of insights. Most of Netflix's server-side architecture has historically been in Java, so a lot of this is already built up and hardened, and there's many years of work that's gone into having really great operational insights on the Java side of our stack. So when you're moving to a new architecture like Node, you can easily overlook how much new ground you have to cover in terms of figuring out what's the right way that you're going to do that within your company, and hardening that, rebuilding that infrastructure and tooling. So we started out with a framework that didn't give us really great insights into what was going on with the application, and we moved to using Restify, which is the REST framework we use today, because it kind of has a lot better insights built right into the framework. So that gave us a lot more observability into what was happening with the application. So that was important, something that we had to kind of do the growing pains to learn. We also learned the power of tools. Again, a lot of really great tooling we'd already built out on the Java side that we had to re-figure out and learn. So things like CPU profiling and flame graphs and core dumps and memory leak detection. There's a lot of great work that's going on in the community right now around this, but definitely we need to put a lot more energy and focus into that so that it can be really easy to use these tools. They're still not extremely easy to use for developers when there's a production issue and you need to get something figured out quickly. you can't have a lot of ramp-up time in using those tools. And so that's definitely something that we all need to put more energy and focus into. Then we've done a lot of work on continuous integration, building out deployment pipelines that are really easy. So using things like Spinnaker and Jenkins, which Spinnaker is a tool that our engineering tools team is open source. So getting a really great pipeline and continuously automating and testing. The website team now pushes multiple times a week, and they were able to get through that through the efforts of the continuous integration deployment work that they've done. So now I'll talk to you guys a little bit about the future. So this is about where we're going. So today at Netflix, Node is used in production for our entire website, but the rest of our client devices that run on mobile applications and TV-connected devices are not necessarily using Node there. So there's probably, I'd say, about a 30-plus person team that's working on the Node stack in production, building out the website, as well as all of our acquisition and sign-up layer. But we're really working on building out Node for a platform as a service within Netflix so that anyone can easily stand up Node applications and get them deployed to production without having to worry about the infrastructure and scaling concerns. So building out all that really rich operational insights and getting that working is not something we want every client team to have to worry about. Or even worrying about the auto scaling rules for their servers is not something we want them to have to worry about. So we're focused on a containerized platform where people can just write their endpoint data scripts, or they can write their Node applications and very easily deploy those. So we'll decide for them like the Node runtime and the REST framework, and then build out all of the metrics and logging around that. But there'll be flexibility within that where they could drop down and have more capability, but then they might have to fall off the supported well-paved road in that if they go that route. So we want to provide a lot of flexibility because we can't anticipate every team's need. We want to build out something where they can kind of run ahead of where the platform might be, and then we can bake that stuff back into the platform as those patterns emerge. So we're providing a lot of flexibility. But you just might not be on that well-paved support path. So where we're bringing this initially is to our data access layer. So every client team at Netflix, this is our current architecture. So all of those client applications that are running across the hundreds and hundreds of devices that we have, they all talk to our edge service layer, which provides data access for the hundreds of microservices and mid-tier services that provide all different kinds of data for you that feed into the application. Today, those client teams they're able to write scripts against a centralized API. So basically think of it as an aggregation layer that pulls together all those services and provides one API that the teams script against. And they write those scripts in Groovy and deploy them directly onto the edge service layer. So it's been really great for us before we had this architecture, we had a REST API where every time you wanted any data on the client, you had to make separate requests for it, which was really not performant for client applications. Now with this architecture, teams are able to get as much or as little data as they want when they want it, and it's very tailored to the needs of their client application. But there's some real problems that we've had. This has been in production now for, let's say, 3+ years. There's some real problems we've had with this. The number one problem is that that's a monolith. It's huge. This edge service layer, you cannot even run it locally. It's just such a huge Java application. It's really hard to even run locally. So all these people who are writing their own client scripts to do data access, they can't easily debug and test that without having to upload it to either our test environment, and that's a slow process. And then there's what do? You do print statements. So by moving to containers and breaking out some of the stack, we're going to be able to really improve that experience for people. And then, they're writing in Groovy, but most of the teams are writing in JavaScript, so that's another pain point. And then we don't have good process isolation in this architecture because anyone deploying those scripts can affect the entire edge service layer and effectively take out Netflix if they, did something that was like doing a bad process or something run away. That has happened in production. So this is the new architecture that we're moving to, and that container layer is going to be Node applications. So now client teams will be able to write their data access scripts in JavaScript and deploy them as Node applications. or they could even just write other kinds of Node apps that they want. So allow teams to be even more flexible in terms of their needs, but also give us really good isolation of the different teams. So each of those boxes you could imagine is a different client apps. So, if you're the Xbox or the PS4, you might have your own container with your own Node application running. So that gives them a lot of flexibility to innovate in whatever way they want to and move really quickly while isolating our edge layer and each other from, if there's any problems. So it allows us to scale and have better availability in the future. So that just talks about it. And then in terms of the developer experience, because we're going to be running Node and containers much more lightweight than the monolith Java app that the Edge is today. So people will be able to run that locally, debug it, set breakpoints, step through code. The developers are chomping at the bit for this. Every time I talk to people, their basic answer is like, this can't come soon enough because it's such a painful development workflow and experience from today. So that's something we're really excited about, making sure that I have a really great deployment pipeline. Obviously with the containers, we're really excited because we get good reproducibility all the way throughout the pipeline. So we know that what we've tested and deployed are the same thing. In terms of performance, we're working on a new application protocol called Reactive Socket, which will allow us to do reactive streams and be fully duplexed, non-blocking, async. So that's part of the performance angle we're going after, is using new technologies in the stack that will give us much better performance. We even want to use that on the client side all the way through and back to the middle tier services so that we can stream data really quickly all the way through the stack. That's something I'm really excited about and eager to see us achieve and start prototyping around what the benefits of that could be on the client. This is just a little deeper dive into what things look like inside the container. So obviously Node, we're using Restify. We're also using Falcor as our data access layer. And the edge service layer is going to be its domain model will be Falcor. So essentially client teams can ask for the data that they want and then do transformations at this layer, but get all the data from the edge service layer over Falcor as well. And then as a side note, because Netflix is such a Java-based ecosystem, all of our Netflix OSS and cloud ecosystem is all Java. We run a sidecar called Prana, which gives us essentially all of the great platform services that have already been built in Java. So we don't have to first class those clients in Node and then maintain them and bug fix them and keep them running in parallel to the Java clients. It's an interesting long-term technology strategy discussion about what's the right long-term approach as Node becomes more important within our stack. Is that the right thing? There's definitely some trade-offs with running this sidecar, like performance being probably the number one, and then just complexity. If we first class those clients, then we could get rid of that sidecar. Right now we have to run that right on the side of the Node runtime. So there's some real benefits we get out of that right now, especially when we're in the early stages of becoming more polyglot. And other teams are using this for Python and Go and other things. So this has been really valuable to us. Just an open question about how important does Node get over the long term, and should we first class those clients? And just to talk about some of the technology, this is like a smattering of all the technologies we're using in the new architecture. Extremely cross-functional project, involves UI platform and my team working on the Node platform, as well as the cloud platform team who's working on Titus, which is going to be the thing that handles some of the scheduling and resource management for containers on top of ECS, which is Amazon's new EC2 container service. Obviously, we're using Docker. I mentioned Prana, Reactive Socket. Curo is for load balancing and back pressure, and Falcor for data access. So a lot of, also our engineering tools team is extremely involved, doing a lot on the deployment pipeline and tooling for developers. So a very cross-functional project. We're hoping to canary in production in Q2, but we're right now running right alongside our cloud platform team because they're just building out some of this. Right now at Netflix, we're only running containers for batch jobs, and there's no services running containers in production. So this is going to be a really big effort. The long pole, in my view, is really a lot around the operational insights, because right now everything about our ecosystem assumes, a single instance, and now we're moving to containers, and we have to really rethink how all of our metrics are being published and all the insights that we're getting. So we're going to start probably with a one-to-one model, or just run one container per instance and see how far we can scale that out. Because we can probably get pretty far and get a lot of the benefit, especially on the developer workflow side, from standing up this stack and then iterating on it. And then the cloud platform team in the background can start changing how they're managing the resources and start changing how they're deploying the containers. So I already handed out all the stickers, so I actually don't have any more stickers, but hopefully all you guys got some stickers. And so I'm definitely open to take questions, or you can come talk to me after. Yeah.
As you move to that container layer, what is the edge layer?
They're still going to run Java. I think they were planning to run on containers too. I don't see why they wouldn't, but they're going to still write everything they're doing in Java.
Could you really talk a little bit about the reactive socket, especially versus just doing WebSockets or real-time?
Yeah, so we'll probably start off doing reactive socket over WebSocket or TCP for Node. It's also interesting, some of the teams are using Aaron, but we don't have a solid story around that yet. We're just starting to build that out. On the client side, we're really limited by the device's capabilities. So some teams will only be able to do HTTP, some teams will be able to do HTTP2, some teams have WebSocket. So it's just really going to depend on what our device capabilities are. But for the devices that we have more control over the platform, like our TV connected devices, where we provide an SDK to partners that they integrate, that they integrate onto their devices, there we can actually start opening up some of the lower level like UDP or TCP and using that. So that's something that we're interested in exploring. The challenge there is that to see a TV device get to market is like a 3-year turnaround time frame. So anything we want to do, we know we're not going to see at volume and market for several years. So we have to kind of work on that now if we want it.
I saw you were using Elastic Container as well as Docker. What is the use case?
I'm sorry, I missed the first
I
one.
saw you were using Amazon EC2 Elastic Container Service as well as Docker. So what are the use cases?
Well, everything we do at Netflix is run on top of Amazon's cloud services, so we want to use what they're providing. And they just, I think at their reInvent last year, they announced ECS, but they're actually making a lot more progress on it now. So we're working very closely with them on our use cases and needs there to make sure that they're building something that's aligned with our needs. And they're actually starting to move a lot more towards open sourcing, and they're very interested in people contributing back. So there's a good cycle going there in terms of contribution and them taking into consideration those different companies' needs.
You talked about the reports of insight.
Yeah.
Can you talk about you guys do anything from the client?
Yeah, we have a lot of logging that we do from the client. We have a library that we use on the clients called consolidated logging, because we used to have a lot of disparate logging across many different endpoints and servers, and then we consolidate all together, so that's where the name came from. But essentially we do application flow logging, so every time you go to a screen, we log about that screen visit. We do a lot of impression logging, so logging when you see a title, so that we can have better insights into how frequently customers are actually playing something versus how many times we've presented that to them. And we use a lot of that data, and it feeds right back into our recommendations algorithms. So we have really rich client-side logging, and then we have good visualization tools that some of the teams have built out that you can go see all of the logs for a client that's been running, and if there's a production issue, someone calls customer support, you can actually debug what's been going on their device and try to figure out what their problem is. Well, oh yeah, yep.
How much code percentage you are able to share between client and server?
I couldn't hear you. I'm sorry.
So you said that you're using one of the regions, you're using Node for a there's common language between client and server. So at Netflix, what is the percentage that you are able to share? How much percentage of the code you are able to share between client and server? Right?
Oh, how much percentage? Oh, that's a good question. I don't actually know the answer to that off the top of my head. I think it's a fair bit because we're using React on the client and the server, so they can reuse all of that pretty much with some caveats because some of the things I mentioned around the module lifecycle and the fact that it doesn't unmount on the server side. So there's some challenges there for sure, but I think we're reusing a fair bit. Okay, that's it. Thank you guys.